Hello, everyone. Hope you are enjoying a fabulous B-Sides SPL 2020, 2022, actually, on the talk how to cribble some things and be useful and CIM, or Common Information Model. Hope you're enjoying B-Sides. If you're from the future and watching a recording of this recording, the weather was nice this week. It's really lovely, and hopefully it's just as pleasant now as then. So for me, I am Gared Seats. I have been doing Splunk stuff for around 8 to 9 years ish professionally, and then I've known about Splunk for over a decade. Back in college, fun times, fun stuff. I did Splunk professional services for several years, traveled around the U.S., seen a bunch of sites, little, small, um, little, small, big, large, the whole gamut of different Splunk environments with the whole list of like some with easy issues, some with difficult issues, and some with no issues, and they just wanted to make sure they were going down the right path. Um, Next will be one of my favorite slides, which is the forward-looking statements. Remember, anything I say forward-looking, it's all imaginary. It's not real until it actually is. So take it in, breathe it in. All right, now for the talk, we're going to be talking about Cribl Stream. Um, so I'm just going to read the slide for you. What is Cribl Stream? Cribl Stream is a vendor agnostic, which is important because this is a Splunk B-Sides talk. So how did Cribl get in here? It's an observability pipeline that gives you flexibility to collect, reduce, enrich, normalize, and route data from any source to any destination within your existing data infrastructure. If you have a buzzword bingo card, you probably just hit bingo right there. But hey, good for you. You're watching the right talks if that's the case as well. One of the key things that we'll talk about in this talk is all those collecting, reducing, enriching, and normalization. Normalization comes important for the common information model because for Splunk, tying everything together is normalizing it. So that way, all your fields and data can actually communicate, so Splunk can be more useful. One caveat, this talk is about Cribl Stream. So you'll hear me use it interchangeably, but not to be confused with Splunk. This is, Cribl is the company, Stream is the product. So they have a lot of other products now, Edge, Search, AppScope, and Cribl Cloud, which is their SaaS offering. We'll skip those for now. We're mainly focused on Stream because for my experience right now, I haven't been able to like really leverage the other ones to a full extent, but I've been able to leverage Stream to help my Splunk life be easier and entertaining, I guess would be the correct word to use for that as well. Some things, what this talk will cover. Again, Cribl Stream. We're going to go over a few basic use cases. Like I said, this is more of like kind of an intro with a few technical details on like what to really watch out for and what to look for. We will have like an odd use case that I've seen and helped work with people to fix. And then a few tips on getting like better data into Splunk. Cribl's really big on like helping people get good data into Splunk, which is awesome. What we won't cover, we're not going to talk about like alternatives to Cribl Stream. There's plenty of them. Splunk DSP, I've heard of it. I have not had a chance to like actually toy or play with it. We're not going to talk about the other Cribl technologies they have, Edge, Search, none of that. We're also going to skip over Inject Actions. It's pretty new. I haven't had a chance to mess with ingest actions at all. So I won't be the subject matter expert that you'll need to talk to for that. But hopefully, one of these other talks and B-Sides, I'm pretty sure they've got you covered. So, some of the use cases for Cribl Stream, and one of the reasons why we decided to go for it, helps to stream data from sources to the Splunk. So, like, we have a variety of different items that we need to get data from. Syslog, the whole gamut, syslog, some HT event stuff, API calls, stuff like that. So you're going to take that to your Stream, pump it out to your Splunk. Awesome. One thing that Cribl likes to tout is the ability to save on Splunk license. We will demonstrate that, and the reason why this is a good thing is because this is data that's not bringing you any benefit, and it's preventing you from bringing good data into your Splunk to really bring out that Splunk prowess. This isn't. This is something that like even Splunk people love because like the more data you get in, the more use cases you get. The more use cases you get, the more license you want. Yada 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 yada. It also can help convert data to be more Splunk friendly. In this case, we'll be going over again a unique log, but the one thing Stream really can't process is binary. But like anything else that's JSON, CSV, TSV, text file, they can bring in and help structure it. Um, One other piece is like helping with storage reduction on the Splunk side. I'll go into more detail later in later slides, but keep that in mind. Also converting fields to be CIM, so common information model, normalizing the data, which is what Cribl as a company says they do. So let's hope they actually do it. Here it helps a little bit more without having to dig into like props transforms. Splunk as a company has actually gotten better at with the product of making this easier as well. So it's really nice to not have to like really dig down into the configs and try to regex your way out of problems, even though you still kind of do. So some of the features in Cribl Stream that you should be focused on. One of my favorite is samples of data. It's not to be confused with sampling, which is a different function in Cribl Stream. So whenever I say Cribl Stream, I'm using them interchangeably, even though I shouldn't. Eval functions, this is basically say, hey, this field should be this should be this, stuff like that. There's a deeper evals that we'll go into as well. Adding comments. Hey, what does this do? Oh, this is what changes this field to this, adds this index, calls it this source type, and then uses this regex to pull out this field. Comments are really helpful, and I'm sure I've never seen anything, 50 functions deep with absolutely no comments. Never. If you want a good example of something to do, go to the pack dispensary, which is right underneath the cloning, and check out some of the packs they have built. There's a sample one. It basically shows you how you should really build a pack or even like manage your pipelines with comments that say what this does and then like how to group them. So perfect stuff. Cloning again, this is awesome if you need to take data, not only send it to your Splunk, but maybe you need to send it to another Splunk. Maybe you have to take firewall data and you have to send it to your Splunk, but then you also have to send a copy to like the sysadmin Splunk. So pretty awesome. You can also just take data and like clone it to like an S3 bucket, cold storage, whatever, while it goes to your Splunk and then goes off to like, a different storage type, so you can keep it for years for all of you people who have to keep data for years for obvious reasons. Leveraging timestamps, pulling timestamps out, getting the right time zone, all that fun stuff, because timestamps are important, and I don't think I've ever heard that any Splunk talk at all, but I'm telling you right now, timestamps are important for Splunk. Really important. Time zones as well. Having multiple routes and destinations. Looking at this right now, you're like, what does that mean? We'll go into it in a couple slides. I promise it'll make sense. Leader worker, HA capabilities, high availability, multiple leaders, one leader, multiple workers, one worker. The worker's essentially like an indexer where it does the processing and the chugging along. The leader's more of like the manager of like, it's the web UI you log into, you can push out configs, all that fun stuff. Leveraging Git to help pull and push configs is pretty awesome as well, and that's something underlying with the Cribl Stream product. Quick Connect is awesome as well. We'll dig into that a little bit. I'll show it later. And then there's also something about goats. You're just going to have to ask someone who works at Cribl about goats, and there's a blog post or two, but I'm sure someone will fill you in. Don't worry about it. Someone will. But then my next feature, which is my favorite, which is critical to success and the only reason why this product is still being used by me, dark mode. Pretty awesome. Love it. Everything should be dark mode unless it shouldn't be. Then, well, who knows. So when you're getting started with Cribl Stream and Cribl in general, top link there, that is their main site. The second link is their sandbox. These are basically consisted of short tutorials where you click on a tutorial and they'll spin up a small Cribl cloud instance for you. You log in, you basically go through a step-by-step tutorial training, and it's phenomenal. It goes through like how to build a pipeline, how to do this, or how to do enrichment with GUIP. Like, we're going to go through one of the sandboxes at least, if not two, that I leverage just to make this talk, because it's easy to use their stuff because easy screenshots. But it's great for a beginner, and I recommend going through all the ones that apply to. Once you do that, go to the Cribl.io University, and that's where you really start hitting rubber hits the road. The university is broken out into two segments. There's the CCOE user, which is Cribl Certified Observability Engineer, and the user admin. User is brand new to Cribl, brand new to Stream, trying to learn this stuff, mainly focused on Stream stuff, and then you basically go through it, goes bunch of videos, tutorials, step by step. Part of the sandbox training, uses it as well. It's phenomenal. Love it. Admin goes a step further, teaches you more advanced functions, digs deeper down. Some of the stuff we'll get into is both in the user and admin. And you also get certifications, which is fantastic, because that way you can prove, like, yeah, I kind of do know Cribl a little bit. And as the admin, more advanced knowledge on Cribl, so like whenever you get thrown a curveball, like, oh yeah, I definitely know that. But it's phenomenal. It's currently free. They say it's always going to be free, so as of right now, it's always free. Log in, test it out, go through it. The only commitment and cost is time, but I think it's definitely worth it. So here is the bigger diagram of Cribl, and I'm going to click over here, get my fancy laser pointer out, and go through the steps on how data goes from whatever to Cribl. So in Cribl, you have the main pieces of the sources, the routes, and the destinations. So sources is where data comes in. This can be like a syslog. This can be a TCP port, UDP port. This can be an S3 collector setup. This can be an HTTP event collector. This can be like API calls. Like, this is where the data comes in. So data comes in, and then it goes to a few routes. One is it goes to pre-processing pipelines. Now, take a step back. A pipeline is like a series of functions that can do certain things to your data. So this is where you would put stuff that you want to make sure happens to everything comes in this source. So if you have a syslog and it's all Palo Alto, well, maybe you want to deal with like a Palo Alto processing and cleaning up at this section instead of waiting all the way down here. Or you need to split this off. Like, you need traffic to go one way, threat to go another, stuff like that. This is where the pre-process comes in. One thing that's not mentioned here is there's an event breaker setup, that if you have event breakers set up, so like CSV, for example, there's a CSV event breaker that'll break up the CSVs into all the fields for you, because it's a CSV, commas, easy to break up, but it breaks up here and it goes here. And this is before the pre-processing pipeline, so you have to be careful if you're going to use event breakers, or if you're going to try to use your pre-processing pipeline functions to do the breaking of events. Now, after this, it can either go through a pre-processing pipeline or skip it and go straight to the routes. And the way the routes work is basically what you see here. Starts at the top of the list of routes, and we'll show you an example in a later slide. Goes down, filter, does it match? No. Does it filter, match? No. Filter, match, yes. Then it goes through. One caveat is to always make sure you have a catch-all. So if something doesn't match, it goes here, and like, have it send a test message to Splunk that says, hey, something went to your catch-all pipeline, and that shouldn't have. Here it is. So that's one thing to keep in mind. Once it goes through here, it can go through either a pipeline or a pack. I'll get into that in a second. Then it goes to post-processing pipeline. Again, another group of, a pipeline that can have functions grouped together and process the data right before it sends it to destination. So you have one go to Splunk. They can all go to Splunk. They can go to, an S3 storage, or they can go to another Cribl instance where they get sent to another Splunk. So let's backtrack a little bit. Back to the beginning. There's this other pass that does a quick connect. What the quick connect does is bypasses everything. It says, I don't care. I'm not going to do pre-processing. I don't want you to go through routes. I don't need this either. I know exactly what the data is. It's going to go to here. I want to do this specific things, and then I want to leave here. The difference between the pipeline and a pack. Pipeline is like one group of functions. A pack can be a group of functions. So you could have one does like one pipeline can do like just GeoIP information, filtering, logging, and like breaking it up, and then another one does like enrichment of something else, and they can be broken up into different packs or pipelines. It's basically the pack is there to help you break out your pipelines, so you don't have a pipeline that's like 75 functions deep and no comments, and you don't know like everything has to go through every single function. Where with Palo Alto, for example, I don't know why I'm on a Palo Alto kick, but it works. Traffic can stop at the top because you're not going to enrich it at all, or you are going to enrich it, but you want to send somewhere else. So instead of going through one pipeline, you want to send it to pack, and it skips all the threat related pipelines that you don't care about, and you only want to go through the traffic one. Helps to reduce load. It's kind of more efficiency based. And again, go to Cribl's website, the pack dispensary, and look at example packs and see how they're set up. And you're like, oh, that makes so much sense. So now that you have the basics of Cribl Stream and how it goes from one to the other, we're going to show you an example of, again, my favorite function, which is the sampling function. And what is awesome with this is here you can see the input. So this is data coming into Stream. And what I'm doing is I'm getting a real-time collection. So imagine like a TCP dump of like listing on the thing. This is listing on the wire. And this is showing me exactly how the data is coming in. Here I have it before the route. So if there's a pre-processing pipeline done before this, I would see this here. But this tells me exactly what the data looks like, time, host, source type. Like you can see it's coming in with a source type. Here's the source. It's already got an index before the routes. And underneath this, you save this sample, and then you can actually check it against your pipelines to see how it functions. We're going to go that deeper in the next few slides. So let me do this. And so going back, like what about that CIM thing, the normalization? For most of them, you're just going to leverage the eval function. This is what's going to help you say this field is actually this field, this field's this field. And it's kind of that simple. We'll go into a little deep, like what you could leverage to try to make sure you're CIM compliant. We're also going to go into another quirk, I would say, of like what you need to remember when you're doing this based on like what your end goal is for Splunk. So one of the other big things that Cribl Stream likes to tout is their GeoIP enrichment. And this is important like a security setting because when data comes in, you can use geo checking on the Splunk side, but if you're archiving data for like months and months, you may want to know what the IP was when it came in instead of what it says there. And being able to add that to the data itself is extremely helpful. It all goes on your use case because like you're going to add more storage because you're enriching it into the data itself. So those TSIDX files will have all that GeoIP information. So like I said, knowing the IP, adding it, and then being able to use the eval function, you can downsize some of the field names because the last time I looked, the MaxMine, when I added it, it was like 5 to 6 words, and there was English, German, Russian, something else. Like there was a lot of languages because that's what MaxMine does. So being able to use an eval function like, hey, I only care about English, or I only care about this language, and instead of using the whole field name, I'm just going to like shorten, GeoIP MaxMine city to just source city or destination city or even DC if you want, or GeoDC. Like you can shorten it out to like 5 characters instead of like 55 characters. So keeping that in mind, like that's really leveraging the power of like Stream and different things. And I'm sure Splunk has something up their sleeves to do that as well. I just haven't leveraged it. So that's what I'm going off of for this. Going deeper, once you can start running like security use cases. Well, if I'm adding GeoIP information, maybe I want to check for like compromised IPs as well. So not only do I know that this IP comes from some foreign country or some unknown state or some unknown, like I should only be getting, I'm in Rhode Island, why is any traffic outside of Rhode Island coming to my shop? Bad use case, but there you go. And then you can compare it to like a list of IPs and use that to enrich. That says, oh well, this is a bad IP that we've been notified that is bad, and we should actually enrich it and say, hey, this is bad. And there's actually a really good sandbox use case that goes over this, adding GeoIP and threat intel. Top link sandbox course enrichment. Step by step, you go through the thing of like not only adding some GeoIP information, and when you see the after effect, you'll see what I mean when it adds a bunch of language, but that doesn't go into that. But you can see it, and it's awesome to see because you're like, oh wow, this is really enriching because it gives you like city, latitude, longitude, stuff like that. And then the IP enrichment is using an IP compromise list, like, hey, these IPs are bad IPs. If you see one coming at your network at all, you should probably alert your SOC or alert your security team that this is happening. So you basically take that, you enrich it with information that you have into Splunk, and you kick it off in like, even if you just have Splunk core, because you can say, hey, this is bad IP, look into it as an extra field. Which, this is another threat intel blog by Cribl. It's actually Claudio Cruz. I hope I said your name right. It is a great blog post. It basically kind of goes step by step on setting up threat intel and stuff like that. But if you focus on just like the Cribl and Splunk pieces on like what he's doing at a high level, it's a very good like, oh yeah, he's enriching, he's matching an IP, he's doing this, and like that makes sense. In fact, this next slide will show a little bit of what he did. A couple of the screenshots from his blog post on Cribl's site. Definitely give it a read. It's phenomenal. So let me do this. So going over this, here we can see he basically going into the enrichment, but he's looking at simming for network traffic. Dest IP, this is what it's called. He's using Bro as an example, which is pretty common for a lot of places to use for sensor. So like Bro calls it IDP, ID underscore REST service. It's like, I just highlighted these because in the next slide that I have, this is actually on the data model normalization for network traffic. There's action, bytes in, bytes out, channel, dest. Like, these are the fields that Splunk is expecting to actually like leverage the common information model. Like, if you start going down the ES route, this is extremely important because you either need these fields, like here, some of it's required for certain things, and others are just recommended, but you should probably check what's recommended and what's required, and being able to leverage that to its fullest extent, because this is where the like rubber hits the road for like Cribl Stream and getting data in that's already CIM compliant. And then like if you convince like we need to do ES, you're already there. Like your common information model, all your data is ready to go. You're gonna off to the races. Instead of like going ES and trying to build up your use cases, you may have use cases like right up there where like all the data is normalized. So it's perfect. A lot of work, but it is what it is. So let's get rolling. So now this is going to be the scenario I mentioned before where like we had this crazy like unique log coming in, and it wasn't too unique. It was a CSV file type stuff, but it was different than what I would normally expect, and it was massive. So let's get rocking again. And the scenario is basically a CSV of NetFlow data. So one, it's NetFlow. So we're talking a lot of data. For this scenario, it was over a terabyte. It was a few terabytes of data. And it's NetFlow, so it's massive. Structured, oddly, I won't call it oddly, it was structured differently. It wasn't structured for Splunk. It was in a time before Splunk. And when I looked at it on paper, I'm like, oh, yeah, this kind of makes sense. But, like, for Splunk, it didn't make sense. We were using Splunk forwarders, and we were doing index time extractions for all fields. Keep that in the back of your head, because I'll mention it later. And for us, we were switching to Cribl to just bring in data source because we had, like, a larger use cases that just Splunk forwarders and heavy forwarders would take. It wasn't going to scale to the degree of, like, how much data we were planning to bring in. So it is what it is, but hey, what can you do? So this is a very sanitized, stripped down version of what we had. Some of the big notes to note is a lot of the fields at the beginning. There's an epoch timestamp. There's a human readable timestamp. Site information, which is like what data center is from, what type of log it was, protocol. Then you have source IP 1, 2, so all the segments of that IP, and destination port, source port. Some of it was like, oh yeah, I know what it is, but then, like I said, this is just the basics of what I could sanitize and put together, and this is pretty much what it was at a shrunk down rate. Um, but like all these fields were going into Splunk, all these fields were index timed, all these fields were index timed. Why is that such a big deal that they're just coming at CSV? So what else are you going to do except index time it? So that way it fields all match up pretty quick, and then you can do fields.conf and just normalize the fields. Yeah, but whenever we started digging into this, we were noticing that all the data was coming in, and it's a lot of data, but for like every gig of data that was coming in, it was taking up around 3 to 4 gigs of data on disk, depending on how high cardinality it was. And basically, the TSIDX files were just massive. And for our scenario, this was like a smart store setup. So, massive data, small buckets, getting rolled quickly. Like, it wasn't great. It was NetFlow, so it was a massive chunk of the license. So a lot of these fields, which are duplicative, were taking up license usage on top of just being NetFlow. So it's NetFlow, and then it was structured in a certain way, and like I said, it wasn't Splunk friendly. If I look at it like on an Excel spreadsheet, I could read it basically. But going into Splunk, I don't need to read it as Excel spreadsheet. I need to see it as Splunk. And again, this is one of the primary use cases for the Splunk instance, so it's important. The issues: you have 3 timestamps. You have underscore time, which gets generated by Splunk, or in this case, stream. You have the epoch timestamp, which is hard coded into raw, and then you have the human readable timestamp, which is also hard coded into raw. All the IPs were mentioned multiple times. All the IPs were one long number, so all the octets were put together, no dots in between. And then each IP segment was its own field with its own, field name. Again, all index timed. And then all the TCP flags were extremely verbose because it was basically the whole handshake of the segment, so it was massive for many of the events, and that's just the way it is. So what did we do? We leveraged Stream to try to break it down a little bit. So first thing is, in this screenshot, this is basically the starting point. There's all the functions we kind of leveraged. There's one sample of the raw. I think this is the one I showed you before. Going in, sample, that way you can see like what each function is doing, how it can do it, turn them on and off, and then I'll show you that in a bit, like how it works. But for us, like the parser function was doing the CSV breaking, or we had a CSV event breaker, but we were leveraging the parsing function. So now it broke out all the fields, made sure all the fields were set correctly, stuff like that. Then we decided to break it down a little bit to where we use source. We basically merged them all together and just did this concat. There's probably better ways to do this, so keep that in mind. Destination port, index, site, lowercase, TCP flag, lowercase. These are just extra functions to like show you some other value expressions you can use in a simple eval. So making everything a lowercase, doing just this index field is going to be this, like a static field, and then this does DST port becomes this DST port. So just keep in mind, like, this is just me showing some more functions. This isn't exactly what we did, but this is kind of what we did. So next slide, this shows the serialization. So you can see here, we took out the 2 timestamps, and we took out all the middle segments, and we just used our combined source and destination fields at the end. You can see raw is now starting with site instead of starting off with 2 timestamps. So we basically dropped the 2 timestamps because at our point we were like, we trust _time, and we didn't need the timestamp in the raw event. We were able to do that, and we were able to change raw again by, instead of having the IP address essentially show up twice, we broke it down to just once, and we just dot segmented it. So to go to the next slide after that, you can see like, well, why are these red down here? Basically right here we're removing the fields, and we're only keeping these fields. So we also decided to add the source type netflow, just for this example. Why did we do this? For our use case, storage cost was very important to us. So even though we'll do data models on some of the data, stuff like that, which we could do it with the Cribl layer, it was determined like, we can have the fields in raw, and then we can do like fields.conf and like set that up in on the Splunk search head. Make these search time field extractions instead of index time search extractions. Save on disk space, save TSIDX. A little slow on the search, yes, but for the specific fields, it is what it is, and overall, this is what we need to do, and like this was our primary use case. So for this example, raw went down 29%. Think about that. That is the license usage of Splunk is raw. So we dropped the license usage in this sample, in this example, by 29% by just doing those like 5 functions: serializing, dropping, and then and it works. For our scenario, it works. Full length event dropped a lot. Number of fields also dropped, but that's just because we went from CSV, which was index time everything, to just the 11 fields we kept. All the other fields in raw are still there. The TCP handshake was still there. Like I can go back and you can see the ACK, SYNAC, ACK right there, and it's still in raw. So in our use case, we shrunk it down even more. For this example, I don't need to go that deep. So going back here, raw, full length, number of fields, number of events, great. So in the original scenario, it was 53 fields. So it's, like I said, these are massive events. 53 fields, millions of tens of millions of events coming in all the time. Like I said, terabytes of data. Many of the fields were high cardinality. In fact, I'd say probably over half of them, because like sequence numbers, bytes, all that it's just duplicative of in the fields themselves. So stripping it down, again, 11 index fields were the ones that we hammered on, and for that scenario it was a 36% reduction. So if you're talking about a terabyte of data on your license and you have a 36% reduction, that's 360 gigs saved off your license, and it's just those like 5-6 functions on like the CSV file, not to mention the storage savings. The storage savings was immense as well. We went from like every 1 gig of taking 4 gigs of disk to like closer to 1:1 to 1:5, or 1:5, I should say, which is what Splunk says their compression rate should be. But if you're index timing everything, the compression rate goes straight out the window. So that is always something to keep in mind, that when you're leveraging these other tools to be used with your Splunk, try to think of all the scenarios you can use them in, like how they can help, hurt, and like what benefits you can get from them. Because like this title could have been like how to shave 36% off your license, but this is going to be different for every single person. And it's a case by case, like what's important to you. Do you need these fields? Can you actually drop the fields completely? Maybe not, they're duplicative, but they're not useful. Like you never use them, they're not there, they're never going to be useful. They're just going to take up disk space because they're part of the raw. And taking those scenarios in place, because like long term, when you're having to keep data for like 12 months, 15 months, several years, every bit and byte adds up. So I would like to thank everyone. This talk was not turning late, I promise, because it's never late, nor is it early. It always arrives when it precisely means to. And sorry about that little laser pointer that was there, but it is what it is. So I just want to say thank you and questions.